Welcome to the final chapter of Level 1, Think Like a Tester. Throughout this journey, you've learned how experienced testers observe software, discover hidden risks, and execute testing professionally. But today, Emma wants to challenge one last assumption. Is testing really the final goal of QA? Or is there something bigger? In this final part, you'll discover how modern organizations build quality long before testing begins and continue improving it long after software is released. Today, you'll start thinking beyond testing and begin thinking like a quality engineer. After the successful release of Phoenix Bank's internet banking system, the team gathers for a retrospective. Instead of asking how many bugs QA found, Emma asks a different question. How many bugs did we prevent? The room becomes silent. That's the difference between a tester and a quality engineer. Modern QA isn't measured by the number of defects reported. It's measured by how much risk was prevented before customers were ever affected. In this module, we'll explore that new mindset and see how quality becomes everyone's responsibility. By the end of this module, you'll no longer see QA as the final checkpoint before release. You'll understand the difference between a traditional tester and a quality engineer, discover why quality belongs to the whole team, learn how quality flows through every stage of the SDLC, and understand the skills needed for the next stage of your career. These concepts will prepare you not only for Level 2, but also for working in modern agile teams where QA creates value far beyond executing test cases. Emma draws 2 columns on the whiteboard. Under tester, she writes find bugs. Under quality engineer, she writes prevent bugs. She explains that both roles are valuable, but their thinking is different. A tester verifies software after it's built. A quality engineer influences the product much earlier by reviewing requirements, discussing designs, identifying risks, and improving development practices. Instead of asking, does it work, they ask, how can we make sure it never fails? That's the mindset modern software companies are looking for. Emma opens the project timeline and points to the requirement phase instead of the testing phase. Imagine the business requirement is misunderstood, she says. Can perfect testing fix the wrong requirement? Of course not. Quality begins the moment a business idea is created. Every requirement, design decision, and coding practice shapes the final product. Testing is important, but it's only one checkpoint in a much larger quality journey. Great quality engineers understand that preventing mistakes early is far more valuable than discovering them later. Emma asks each team member one question. What do you contribute to product quality? The business analyst ensures correct requirements. UX designers make the system intuitive. Developers write reliable code. QA validates behavior. DevOps guarantees stable deployment. Support teams collect customer feedback. Suddenly, everyone realizes quality isn't owned by QA. It belongs to the entire project team. A quality engineer helps connect all these roles, encouraging collaboration so that quality is continuously built instead of inspected at the end. During sprint planning, Emma notices that one acceptance criterion could be interpreted in 2 different ways. Instead of waiting until testing uncovers defects, she raises the concern immediately. After a short discussion, the team updates the requirement before development even starts. Hours of future debugging disappear because of a 5-minute conversation. This is the essence of shift left, bringing quality activities earlier into the development lifecycle. Every defect prevented before coding saves far more time than fixing it after release. The banking application has been released successfully, but Emma's work isn't over. She reviews monitoring dashboards, customer feedback, production logs, and usage analytics. She discovers that users frequently abandon the login process, not because of a bug, but because the interface is confusing. That insight becomes an improvement for the next release. This is shift right. Modern quality engineers continue learning after deployment because real users often reveal opportunities that no test environment can fully simulate. Emma now connects everything into one continuous cycle. Plan, build, test, release, monitor, learn, and improve. She explains that quality isn't a project phase. It's a continuous feedback loop. Shift left helps prevent problems before development begins. Shift right helps teams learn from production after release. Together, they create continuous improvement, where every sprint becomes smarter than the previous one. The best teams don't simply deliver software. They continuously improve both the product and the way they build it. Emma asks you one final question. If every functional test passes, does that guarantee high-quality software? Not necessarily. Customers also expect the application to be fast, secure, reliable, easy to use, accessible, and compatible across devices. Modern quality engineers think far beyond functional correctness. They consider the complete customer experience and every quality attribute that contributes to trust. A feature may work exactly as specified, But if users find it slow or insecure, quality has still failed. That's why quality engineering always looks beyond functional testing. Emma projects two numbers on the meeting room screen. The first is the cost of fixing a requirement mistake during analysis, just a few minutes of discussion. The second is the cost of fixing the same mistake after thousands of customers have used the feature. Emergency hotfixes, overtime, customer complaints, compensation, and damaged reputation suddenly make that tiny mistake incredibly expensive. Quality isn't expensive, Emma explains. Poor quality is. That's why quality engineers invest their effort in preventing defects early instead of paying the much higher price of fixing them after release. As the team reviews a new payment feature, everyone seems satisfied because the acceptance criteria are complete. Emma isn't finished. She asks, what happens if the payment service becomes slow? What if customer data is lost? How will we detect failures before customers call support? These questions aren't about proving the feature works. They're about discovering hidden risks. Great quality engineers don't stop at validating requirements. They challenge assumptions, anticipate failures, and encourage the team to think about reliability before problems occur. Emma opens the team's dashboard. Instead of asking how many bugs QA found this sprint, she points to metrics like defect leakage, test coverage, automation coverage, escape defects, and mean time to resolve. These numbers tell a story, she explains. They show whether we're improving or repeating the same mistakes. Modern quality engineers use metrics to guide decisions, not to judge people. Without meaningful measurement, improvement becomes guesswork. With the right metrics, teams know exactly where to focus their next quality investment. A production incident occurs after release. Instead of asking who caused this, Emma asks, what allowed this to happen? The team performs a root cause analysis, updates their coding guideline, improves automated tests, and adds a new requirement review checklist. The incident becomes an opportunity to strengthen the entire development process. That's continuous improvement. Every defect teaches a lesson, and every lesson helps prevent future problems. Great quality engineers improve not only products, but also the way their teams work together. Emma shows how the QA profession has evolved over the years. It began with manual execution, then introduced structured testing, automation, and today has expanded into quality engineering supported by AI. Although tools continue to change, one thing remains constant: the mission to deliver better software. Modern QA professionals don't simply execute test cases. They collaborate across the SDLC, automate repetitive work, analyze quality data, and increasingly use AI to improve productivity. The role has grown from tester to trusted quality advisor. Emma asks a simple question: what makes someone a great quality engineer? It's not only testing knowledge. Great QEs understand business goals, think critically, communicate effectively, work with APIs and databases, automate repetitive testing, understand CI/CD pipelines, analyze quality metrics, and leverage AI tools. No one masters every skill overnight. Your career grows by expanding one capability at a time. The broader your skill set becomes, the more value you create, not just for QA, but for the entire development team. Emma reminds you of your first day on the Phoenix Bank project, when simply writing a test case felt challenging. Today, your perspective has changed. Every project, every defect, and every retrospective contributes to your growth. The journey from newbie to junior tester, senior tester, quality engineer, QA lead, and quality manager isn't defined by job titles. It's defined by continuously expanding your mindset, your technical skills, and your ability to influence product quality across the entire organization. Before ending the module, Emma asks everyone to pause for a moment. When you test a feature, she says, are you only finding bugs? Or are you reducing business risk? Do you understand why the feature exists? Do you help your teammates improve? Are you continuously learning beyond manual testing? These questions don't have right or wrong answers. They're reminders that becoming a quality engineer begins with self-reflection. Every improvement starts by honestly evaluating the way you think and work. Let's summarize the mindset shift you've made today. Testing is only one part of quality. Quality begins with business requirements, not test execution. Every member of the project team contributes to product quality. Great teams prevent defects through shift left, learn from production through shift right, and continuously improve using data and feedback. Most importantly, a quality engineer creates value by preventing problems instead of simply reporting them. That's the mindset that distinguishes modern QA from traditional software testing. Now it's your turn to become the tester. Emma opens the internet banking login page and says, forget everything you know about this system. Imagine you've just joined the project today. Your mission isn't to execute test cases yet. Your mission is to understand the feature. At first glance, the screen looks simple. A username field, a password field, and a login button. But experienced testers know that behind this simple interface may hide security risks, business logic errors, performance issues, and usability problems. Every workshop begins with observation, not execution. Now it's your turn to become the tester. Emma opens the internet banking login page and says, "Forget everything you know about this system. Imagine you've just joined the project today. Your mission isn't to execute test cases yet. Your mission is to understand the feature." At first glance, the screen looks simple. A username field, a password field, and a login button. But experienced testers know that behind this simple interface may hide security risks, business logic errors, performance issues, and usability problems. Every workshop begins with observation, not execution. Imagine you've just joined the Phoenix Bank project. On your first day, Emma assigns you a simple task. The login feature is ready for testing. At first glance, it looks straightforward. 2 input fields and a login button. But Emma smiles and asks, "Before you write a single test case, what is this feature really trying to achieve?" The answer isn't simply allowing users to log in. It must allow authorized users to access their accounts securely, quickly, and reliably, while preventing unauthorized access. Understanding that business goal is the first step of professional testing. Before we test the feature, let's first learn how to observe it. Emma doesn't allow anyone to click the login button. Observation always comes before execution, she reminds the team. Spend a minute studying the screen. What components can you identify? How will users interact with them? More importantly, what isn't here? Is there a forgot password link? A password policy? A show password icon? Sometimes missing functionality is just as important as visible functionality. Great testers don't rush to execute. They collect information first, because careful observation often reveals valuable test scenarios before the first click. Now Emma asks, how should this feature work when everything is correct? The team agrees on the happy path. Enter a valid username, enter the correct password, click Secure Login, and successfully reach the dashboard. This is the system's primary business objective, and the first scenario every tester should verify. But Emma reminds everyone, testing doesn't end here. The happy path only proves the system works under ideal conditions. Professional testers use it as the starting point, before exploring everything that could happen differently. Real users don't always follow the same journey. Some use Remember Me, others reset forgotten passwords, and future versions may support biometrics or single sign-on. Each alternative still achieves the same business goal but follows a different workflow with different risks. Emma explains that professional testers don't think in terms of one process. They think in terms of all valid ways users can accomplish the same task. Every alternative flow deserves attention, because each one introduces new behaviors and potential defects. Emma changes the challenge. Now assume everything goes wrong. What if the password is incorrect? The username doesn't exist? The account is locked after multiple failed attempts? The server is unavailable or the network disconnects during login? Customers judge software not only by successful transactions, but also by how it behaves when problems occur. Great testers spend significant time exploring exception flows, because these scenarios often expose security weaknesses, usability issues, and hidden defects. Testing without understanding business rules is simply guessing. Emma asks, when should an account be locked? How long should a session remain active? Are usernames case sensitive? Should leading spaces be ignored? These rules define correct system behavior. If testers don't understand them, they cannot determine whether the application behaves correctly. Before designing test cases, always identify the business rules that drive the feature. Good testing starts with understanding the business, not just the interface. Not every defect has the same impact. Emma asks the team to rank the risks. A typo on the login page is inconvenient, but a security flaw allowing unauthorized access could have serious consequences for customers and the bank. Authentication, session management, and account lockout all carry much higher business risk than cosmetic issues. Professional testers evaluate both the likelihood of failure and the business impact before deciding where to spend most of their testing effort. Emma asks everyone to change perspective. Think like a new customer unfamiliar with the system. Think like a busy employee logging in quickly. Think like an elderly user who may make typing mistakes. Finally, think like an attacker trying to bypass security. The screen hasn't changed, but your observations have. Different users expose different risks, usability concerns, and security issues. Great testers constantly switch perspectives, because software must work safely and effectively for every type of user. Rather than relying on intuition, Emma introduces a structured checklist. Review input validation, business rules, session handling, permissions, APIs, databases, logging, notifications, and error messages. Each area can hide defects that are invisible from the user interface. A systematic approach ensures important areas aren't forgotten, even under tight deadlines. Experienced testers don't depend on memory. They depend on a repeatable thinking process that consistently uncovers risk. Emma smiles and says, professional testers ask questions before writing test cases. Does the system ignore leading spaces? Is the username case-sensitive? What's the maximum password length? What happens after 5 failed login attempts? Are Unicode characters supported? Every answer removes an assumption, while every unanswered question creates risk. Great testing begins with curiosity. The better your questions, the better you'll understand the feature, and the more effective your testing will become. Now it's time to convert your observations into test ideas. Start with a successful login, then expand to wrong passwords, unknown usernames, blank fields, locked accounts, expired OTPs, and session timeouts. Add boundary values, special characters, repeated clicks, and interrupted network connections. Don't limit yourself to positive scenarios. Design negative and edge cases as well. Professional testers don't wait for requirements to list every test case. They generate ideas by combining business understanding, risk analysis, and critical thinking. Emma now gives the team a new challenge. The release is in 2 hours. You don't have time to test everything. Suddenly, testing becomes a decision-making exercise. Which scenarios deserve attention first? Successful login and account lockout directly affect security and business operations, so they receive the highest priority. Features like Remember Me improve convenience, but carry lower risk. Cosmetic elements such as logos or page layout come last. Professional testers don't simply execute every test. They invest their limited time where failures would have the greatest business impact. One learner finds a bug and excitedly announces, "Login doesn't work." Emma smiles and asks, could a developer reproduce it from that description? A professional bug report needs evidence, screenshots or videos, clear reproduction steps, timestamps, browser and operating system, logs, API responses, and test data. Good evidence shortens investigation time and speeds up defect resolution. Remember, your goal isn't just to find bugs, it's to provide developers with everything they need to understand and fix them quickly. Emma gathers the team around. Finding a bug is only half the job, she says. Can another tester reproduce it? Can a developer understand it without asking more questions? A professional bug report should answer those questions immediately. Include a clear title, preconditions, detailed reproduction steps, expected and actual results, business impact, and supporting evidence such as screenshots or logs. Remember, your report is a communication tool. The clearer it is, the faster the team can reproduce, fix, and verify the issue. The workshop is complete, but Emma has one final exercise. Before you close your laptop, reflect on your thinking. Did you identify the highest risks before testing? Did you ask enough questions instead of making assumptions? Did your scenarios cover the happy path, alternative flows, and exception flows? Professional growth comes from reflection, not repetition. After every feature, take a few minutes to evaluate what you learned and what you could improve. That's how experience gradually becomes expertise. Emma hands everyone a final checklist. Before testing any feature, ask yourself, do I understand the feature's business goal? Have I identified the happy path and exception flows? Do I understand the business rules? Have I assessed the risks? Have I generated enough test ideas? If you can confidently answer yes to each question, you've developed the mindset of a professional tester. This checklist isn't just for today's workshop. Make it a habit for every project you join. Let's look back at our journey. We started by understanding why software needs testing, then learned how professional testers observe software, think like bug hunters, follow a structured testing workflow, avoid common beginner mistakes, adopt the mindset of a quality engineer, and finally apply everything through a practical workshop. Each lesson built on the previous one. Together, they've given you something more valuable than test cases. They've given you a way of thinking that you can apply to any software project. Before moving forward, take one last self-assessment. Can you think like a tester instead of simply following instructions? Can you identify risks, ask meaningful questions, prioritize your testing, and communicate defects clearly? If these activities now feel natural, you've achieved the goal of level 1. You now have the mindset needed to approach software with curiosity, structure, and critical thinking. That's the foundation every successful quality engineer builds upon. Congratulations on completing level 1. You've learned how professional testers think. But there's another skill that separates good testers from exceptional ones. They understand the problem before they design the solution. In level 2, we'll move beyond observation and learn how to analyze business needs, interpret requirements, uncover hidden assumptions, and identify risks before testing even begins. Because great testing doesn't start with a test case, it starts with understanding the problem. Welcome to Level 2, Understand Before You Test. Thank you for joining me throughout Level 1. I hope this course has changed the way you see software testing, not as a task of clicking buttons, but as a discipline of observation, analysis, and critical thinking. Keep practicing these habits on every feature you test. Stay curious, continue asking better questions, and never stop learning. I look forward to seeing you in Level 2, where we'll continue building the skills needed to become a modern quality engineer.